So we saw the 7 layers and the role they do in preparing a packet to be a eligible packet in the network.
Mm-hmm.
So if any one of this layer is absent, if any one of this layer is not added to the data, then the
Mm-hmm.
encapsulation will fail. Meaning what? The packet is not eligible to be sent out. Your
Mm-hmm.
operating system won't send it out. If any one of this, for example, say there is nothing related session layer, chanceless, the packet will not go out. It cannot go, first of all. Or let's say if the destination MAC address is not there, not known. I want to send a packet, but um, the destination address is not known. So what will happen is the encapsulation will fail. Yep.
Mm-hmm.
So the 7 layers are mandatory. Cannot have anything missing there, neither IP address nor the MAC address or the port number. They all need to be there. Session IDs, everything need to be there, and that
Mm-hmm.
should be in that same order which we learned.
Mm-hmm.
Starting from application layer down to physical layer, same order, same sequence. It cannot be shuffled. Next. So there is a sender here, A, and the receiver here, B. He's the one who is going to generate the traffic, so you can call him as an initiator,
Mm-hmm.
and he's trying to deliver that packet to him, so you can call him as a target, or you can
Mm-hmm.
call him as, so this guy as source, this guy as destination. Source, destination, initiator, target, everything is same. Now, source has got IP address 10.0.0.1. Destination has
Mm-hmm.
got IP address 10.0.0.2. Source got MAC address, for example, AAA, BB. Now they want to communicate. Mm, let's say they are telnetting. There's a connection between them. Now, the data and then the presentation layer
Mm-hmm.
means the application layer is generated using data. The presentation layer picks up the protocol, telnet, because we were typing telnet in the application.
Okay.
You may be typing, or it may be a tool where you have a radio button to punch in. You know.
Mm-hmm.
So somehow you tell the presentation layer that please pick that telnet service, and presentation layer does that, and it is marking the packet that this needs telnet protocol. Okay,
Mm-hmm.
fine. If you want telnet, I'll send the packet out in this time frame. So session layer adds its marking, and then session layer forwards it to transport layer. Transport layer picks TCP destination port number as TCP 23, and the source port number is going to be a random port number. Um, let's say 5555, as I said earlier in the previous class. Now, this is what going to be added in the transport layer, followed by
Source
follow,
IP.
yeah, followed by the source IP 10.0.0.1, destination IP 10.0.0.2, How it knows 10002 destination? Because I typed the command telnet 10002 on this computer. So when I say telnet to this, operating system takes that address as that destination and puts it here. And the operating system picks its own address and puts a source. Next. On top of this, additionally, another layer is added, which is source MAC address. The source MAC address is AAA, but the destination MAC address is
Unknown.
so what it does, it uses the ARP protocol. So because it doesn't know the destination, it won't further process this. It will just keep it like this. Okay, I'll use it, I'll send it later. Let me first use the ARP. ARP is a broadcast packet which is sent in a layer 2 level. That's why it's a layer 2 broadcast traffic generating application protocol. So this protocol, what it does is it is trying to find the MAC address of this destination IP. So it prepares an ARP packet separately, saying who is 10002. I'm not telling just for understanding. This is how exactly it will send. Also, this is the exact message it will send, and the receiving device operating system can read this. So in the payload, it is having, when we say payload, it is nothing but the field where the data is carried. That is what payload is. It is putting this information who is 10002, and in layer 3 it puts source address 10001 and destination 10002 and source MAC address AAA, destination MAC address F, 12 times F. That is what called as layer 2 broadcast. Address, layer 2 broadcast address, 12 times F. That's the biggest 48-bit address. Now, this packet, when it is sent out, if there are switches in the middle, the switches will also flood it to all the ports. In our case, there is no switch, so it is going to go here, and when the packet comes here, B is going to look into the destination of the incoming packet. Destination says for anyone, it is for anyone. This is for anyone. Anyone can process this packet. That is what this means, FFFF to B. And B is saying, okay, let me then open and check the destination IP. Is this IP matching my IP? Yeah, it is matching. So I'm going to open further. And in the payload, it is asking like, who is 10002? Then B puts its own MAC address as a ARP reply and send the packet to 10001 with the source MAC address BBB and the destination MAC address AA from where the packet comes. So the MAC address BBB is not only in the payload; it is even in the source field from where the packet is coming.
Okay.
Yeah. So the MAC address is both in the place where the data layer, link layer of the reply packet as well as in the payload. So using that, A is going to, first of all, it will put it
Fill
into
the
the
MAC
ARP table.
address of.
Put the it will update the ARP table saying I learned someone's MAC address is 10002 and the MAC address is BBB. And then what happens is telnet service says, oh, I need that MAC address. Let me put that MAC. Then BBB shoots the sorry, the PC shoots the packet by adding a physical layer encapsulation. The physical layer, maybe Ethernet, so Ethernet standard need to be filled here. The physical layer, if it is Wi-Fi, then Wi-Fi related information need to be added so that the operating system adds it from the driver. You might have installed a Wi-Fi driver, or it may
Mm-hmm.
be there in the Windows operating system already by default. So the driver puts the necessary information so that the trans receiver, the Wi-Fi trans receiver of your laptop,
Mm-hmm.
understands this and send the packet out. Same way when the packet comes in, the reverse process will happen. So this is what we call data encapsulation.
Mm-hmm.
This is what called as data encapsulation. And now, when this packet is sent to B receives it, and now B opens the second layer and checks the MAC address. The MAC address matches. Only then it opens the third layer. The IP address matches, and then it opens the fourth layer. It understands
Mm-hmm.
that A is looking for a telnet service, and B
Mm-hmm.
understands that, and it informs the upper layer. The upper layer provides the necessary information, and again it encapsulates and sends the reply. So if you
So if
see,
it's a TCP
yeah,
TCP protocol,
yeah,
TCP application
yeah,
that uses the TCP protocol, they do a three-way handshake and
yeah, very
then
correct, very correct. Now,
okay,
I did not mention those things because I do not want to make complicated. We are trying to understand encapsulation and
okay,
decapsulation, so I made it short.
okay.
So you remember yesterday I told you any TCP service before they send the actual telnet or HTTP or anything
Mm-hmm.
request, they will first do three-way handshake.
Okay.
Yeah. So anyway, this is what actually going to happen even in three-way handshake. They're going to send a data encapsulation, and it will be
Mm-hmm.
decapsulated on the receiving side, and the
Mm-hmm.
receiving side responds again by encapsulating, and the sending side
Okay.
it is going to decapsulate. So
Okay.
encapsulation and decapsulation of packet happens, and the decapsulation side they remove one layer after the other to
Mm-hmm.
understand how the packet need to be treated,
Mm-hmm.
and now they treat the packet very well and they get the data out exactly the same way it is sent.
Mm-hmm.
B
Okay.
learns the data the exactly the same way
Mm-hmm.
as it is sent. Now we have got the packet to and forth sent and received successfully. It
Mm-hmm.
is all because of OSI layer. If OSI layer is not there, it's not possible.
Mm-hmm.
So OSI is a kind of signaling uh, with various things so that those signals will signal the devices in the middle as well as the devices that receives uh, to whom this packet belong to and how this packet need to be treated so that
Mm-hmm.
the data transfer will be happening successfully. So OSI
Mm-hmm.
is not our data. OSI helps our data to reach where it's supposed to reach
Mm-hmm.
and to deliver the data exactly the same way that we have sent. That's the purpose of OSI. Very important.
Okay.
So this is what actually a network needs to carry our data. When we don't understand OSI properly, we cannot say we know networking. We may
Mm-hmm.
know BGP, OSPF, all those big stuffs, but then we don't know this function that is carried, then it is of no use. I know you're disturbed because of your background noise. Mm.
It's the emergency siren. Sorry about that.
And I hear every now and then. I don't
It's
know.
all the time.
Yeah,
It's all the time.
you're near the hospital.
Yes.
Okay. Okay, let's continue. So recording, sorry, ARP is important for every fresh conversation. The ARP table will be referred. If ARP table is not updated, a layer 2
Mm-hmm.
broadcast will be sent, and the reply comes exactly from that person to whom the packet was actually destined in layer 3. Layer 2 it is a
Mm-hmm.
layer 2 broadcast, but layer 3 has got an exact address, precise
We have
address.
similar thing in IPv4. I think it's the CDP that discovers the neighbor.
ARP is different, CDP is different. CDP is Cisco's protocol, and
Okay.
it's not an industry standard.
Mm-hmm.
CDP not only discovers MAC address, it discovers a lot of things. It discovers the IP address on the connected device. It
Mm-hmm.
even learns the router series number. Means if it is 27,000 series switch, it will show I'm connected to 2700 router, and this is
Mm-hmm.
the interface F00 I am connected to, and this is the IP address on that device, this is the MAC address on this device, and many more things of the neighbor. CDP is more dangerous than ARP.
Okay.
So CDP is like a routing protocol. Periodically updates are sent saying, hey, this
Mm-hmm.
is my MAC address. I'm coming from this particular router, and this is the
Mm-hmm.
operating system on my router,
Mm-hmm.
and this is the subnet mask on the interface and the IP address of the interface. This is the MAC address, and this goes as an advertisement,
Okay.
and the neighbor learns about me. I advertise
Mm-hmm.
it periodically. Every 60 seconds, I advertise, and the neighbor learns me. It is totally different from ARP. ARP is not advertising. ARP is flooding and learning.
Okay.
I ask everyone, is there anyone called 10002? Everyone receives it. No one will answer except the 10002.
Mm-hmm.
And the response is not going to bring IP address or anything else like operating
Other
system
than that.
version. It only brings the MAC address. Right. So IPv4 ARP is bad, as I said earlier. Now let us talk about DHCP. DHCP is also same like ARP, which
Mm-hmm.
sends layer 2 broadcasts. So wherever layer 2 broadcast is, is very dangerous. It's not good. Your
Mm-hmm.
device may get compromised. So how do we uh, prevent? IPv6 is the solution. You cannot have IPv4, a big IPv4 network without DHCP, and
Mm-hmm.
you cannot have without ARP. So these two are always there in IPv4. Now, how DHCP works? DHCP, as we know, uh, ARP stands for Address Resolution Protocol. Likewise,
Mm-hmm.
DHCP stands for Dynamic Host Configuration Protocol.
Mm-hmm.
So this protocol dynamically configures the host with a IP address.
IP address.
It dynamically configures the host with the IP address. So DHCP, Dynamic Host Configuration Protocol. Now, there are four different packets that goes in between the DHCP client
Mm-hmm.
and
With the
DHCP server.
DHCP server.
This DHCP server can be a Cisco router, it can be a VM, It can be a physical device, a server with any operating system, that doesn't matter. So DHCP server can be anything. It can even be a Wi-Fi router in your house, a domestic router, which throws. There are various things which can provide an IP address by running this DHCP service. Fine. So let us assume we have one of the DHCP server, and now let me draw it as a router because we are in routing class. So router is now configured as a DHCP server, and there are many computers. We don't know how many. There are many computers. There are printers and scanners and many more connected to this LAN. They all need IP address so that we can print from all these computers by using this one centralized printer. We want IP address for communication between these computers and the printer, as well as communication between these computers. We need an IP address. So we rely on DHCP service. So what happens is, as soon as we turn on these 4 devices, all these 4 devices are going to send the very first packet called discover. Clients, these are all clients. So we configure these as clients. So all these clients, all these DHCP clients, all these clients are going to send, all these DHCP clients are going to send layer 2 discover packet. Layer 2 discover packet. So
You're recording it, right? Just to be double sure. Okay.
Yeah. So layer 2 discover packet is sent. Now, if this A computer sends it, so if A is sending that, not only it goes to the server, it goes to everyone. It goes to C, it goes to B and D. It goes to everyone because it's a layer 2 broadcast. It goes even to the other clients. But they're not going to respond because the Discord packet is looking for a DHCP server. And in the payload, it will be very clearly mentioned. So only those devices that are configured already as a DHCP server can process it and respond to it. Now, this is responding, and we call it as, again, it is going to be a layer 2C. So far, there is no IP address on this device. Sorry, you cannot do any point-to-point. You cannot have a point-to-point option other than. Sorry, you cannot do unicast other than broadcast. You cannot because you don't have an IP address to communicate.
IP address to do a unicast.
Yeah, there is no communication possible. We're using layer 3 because you don't have a layer 3 address. Now, server also does layer 2 broadcast here, saying I am offering my detail. I am DHCP server. These are my details. So it offers. DHCP server offers. That offer should not misguide us. It's not offering an IP address that you asked for. Actually, you did not ask for an IP address. You are asking for what? Is anyone DHCP? That is what the discover packet is. Is anyone here a DHCP? For that, a response comes saying, here am I. That's the offer.
Okay.
So offer packet is not bringing IP address. It is just bringing the IP address information, the MAC address information, the whereabout of DHCP server. All right, now the client has received an offer. May not be from one DHCP. It may be coming from multiple DHCP.
So,
So there is a Wi-Fi. So there are various devices that provides a offer because you got more than one DHCP server in the location. You might have seen, when you turn on your laptop and look for Wi-Fi signal, you will see your Wi-Fi, neighbor's Wi-Fi.
yeah.
Sometimes if you're in an apartment, you will see 10 number of Wi-Fis.
Yeah.
Which one is yours, and everyone has logged it, and you also have logged it. Others cannot get into yours, so you cannot get into others. Fine now, but offer comes from everyone. When your laptop is opened, on, when it boots, the Discover packet goes, and all DHCP servers in the apartment responds to you. Offer comes from everyone. Now, the DHCP client is now going to pick the one which is given with a credential if it is your laptop. What if no, it is not a Wi-Fi, it is a normal physical network, and we got two routers. We got two routers providing DHCP response, and there is no authentication involved. What happens then? Now, the client needs to choose one of this based on the response. So client will see the response, which one came early, whose response came early. Is it the response of alpha or response of beta? Who offered me first? Whose offer packet came first? Is it alphas or beta? So if alpha's response is first response, early test come before beta gives the response, alpha is given, which means alpha is closer to the client. So it likes the closest one. So to that closest one, another layer to broadcast, which is called a request packet goes. So the request packet is actually requesting for an IP address to that alpha, not to anyone else, not to beta. So alpha now receives a request, and
But this is still a layer 2 broadcast, but it has the destination MAC address in it.
yep, but not all the case. It depends on the operating systems.
Okay.
Even in Cisco, you will have two different versions of document. One will explain saying they will have the MAC address, so they will do unicast. The other will say, no, they will broadcast. All four packets are broadcast. I go with the one which is all four packets broadcast. The reason is when the DHCP is in the same LAN, same what I have drawn here in the picture, it is going to be all broadcast. All four will be broadcast. If DHCP is behind some router somewhere, then we will be using something called relay agent. That is the case where the request will go as a unicast from your gateway to that actual DHCP, because router is going to forward it like that as a unicast.
Okay.
So some people they mix both and they confuse these topic in even in
Mm-hmm.
Cisco document they have confused and they have written like that.
Yeah.
So actually,
Even when I learned it, it was like a unicast.
mm, you know, I know, I've seen the document. So now it's going to be a layer 2 broadcast again, and it is asking for IP address, but in the payload it has got the MAC address, and and now only this is eligible to respond. See,
Mm-hmm.
it cannot do unicast. The reason is it don't have an IP address yet.
Mm-hmm. Okay.
In case if the DHCP is behind here,
Mm-hmm.
actual DHCP, because this don't know the IP address, the client don't know the IP address, it will send a layer to broadcast, and this is the relay agent. So he becomes the source IP,
Mm-hmm.
and he knows the DHCP's IP, which is destination IP, so that that can be a unicast.
Unicast.
But here you cannot expect a unicast. It's going to be a broadcast.
Okay.
So the DHCP server receives the request and
Mm-hmm.
and copies the MAC address of the client in a
Mm-hmm.
table called DHCP binding table,
Mm-hmm.
and to that MAC address it allocates a MAC IP address from the DHCP pool,
Uh-huh.
and that IP address it is sending again as a layer 2 broadcast packet called acknowledgement. And this acknowledgement only brings the IP address to the client. Now, from now
Uh-huh.
on, client can use the IP address for any conversations. So, DHCP uses this 4 layer 2 broadcast packets to get the IP address to unfold.
Okay.
Discover, offer, request, acknowledgement. Fine. So this is also broadcast, that's why it is bad. Then how in IPv6 this can be solved? IPv6 have got something called auto address configuration,
Uh-huh.
where you no need someone to provide IP address by
Mm-hmm.
flooding it like this. The device which needs an IP address can can figure out their own IP address just by taking the global prefix that comes through a multicast packet. More detail we'll see
Okay.
when we go there.
Okay.
So there is no need for a DHCP in IPv6.
Okay.
The DHCP in IPv6 is only needed to provide the DNS address,
Mm-hmm.
for which there is no need for a discover, offer, and all. I'm going to just provide the DNS address.
Mm-hmm.
So it uses a multicast address to deliver that.
Okay. So once we get a IP address, there will be no more discover packets
No more,
going.
no more, no more.
Okay.
Until the lease time expires. The IP
Okay.
address will come with the lease time,
Mm-hmm. Mm-hmm.
like 24 hours or
Mm-hmm.
1 hour.
Okay.
After it is expired, then it will shoot out. And if the
Mm-hmm.
same DHCP is available, the same DHCP will give the same IP address again. So
Mm-hmm.
the IP address get renewed, but it's the same IP
Okay.
address. All right. So that's about the broadcast, which is bad,
Mm-hmm.
and IPv4. So today we have
Okay.
learned about it, encapsulation, decapsulation, and These two features that we have in IPv4 considered bad.
Okay.
ARP and DHCP.
DHCP.
So tomorrow we are going to continue with
Mm-hmm.
another interesting topic called IP addressing,
Mm-hmm.
where we'll know the structure of IP address and the subnetting followed by that.
Mm-hmm.
Yeah. So
Uh,